Let's look at some of the details with these climate and waterborne disease connection. One of the things that matters a lot in hydrological processes is seasonality, because most regions have a rainy season. Like in the tropics, you can have a monsoon season, unless you are in a region like Indonesia or the Amazonia, where there is rainfall throughout the year, even though there is still a high rain season and a low rain season. And that matters because the year-to-year variabilities tend to be focused on some part of the year, even if it's raining throughout the year and so on. That matters also because that means El Nino connections, temperature and precipitation changes together you tend to work on hydrological processes, mosquito populations, or other waterborne diseases where water consumption patterns, water usage, contamination, etc. tend to happen. This is an example of that seasonality. Here are the number of cholera outbreak map for the period of 1974 to 2005. So even a cold place, a relatively moderate temperature range of US and Alaska or even Russia tend to have cholera outbreaks. Cholera, Vibrio cholerae, is a environmental bacterium which means it can reproduce in the environment, unlike some of the others like Campylobacter and Cryptosporidium, which need a host in which they can multiply. Salmonella also can multiply in the environment, I think, for example. We can check that later. So it lives on a certain surfaces of zooplankton in marine waters. It's what is called halophyte. It likes or it tolerates salinity and so on and so forth. But the main message here is that the certain countries like Bangladesh, India, and these Southeast Asian countries, some parts of Africa, have generally higher number of cholera outbreaks than most of the other regions. And there are also questions about whether these are endemic or brought by ballast waters, by people, by some other means into these latitudes. And if it does arrive, does it survive in the open environment, or does it need to be brought in again and again by these various methods? Okay, so leaving that there, we can also look at the seasonality. Here, different parts of the year are different seasons of the year are compared, divided by the total number of cholera events in each location to give you a measure of seasonality. What does that mean? When the seasonality is low, here for example for India it's 0.0 to 0.02, that means basically it can happen any part of the year. When the seasonality index is high, like 0.81 to 1.0 in these regions, that means it's highly seasonal. It cannot happen any time of the year. It's restricted to potentially the warmest time of the year, for example, which can be very short in these very high latitude Siberian Russian regions. Surprisingly, even in this high latitude Tibetan region, it's very seasonal, as opposed to the rest of China and so on, where the seasonality is much lower, so larger part of the year can see cholera. Of course, when we worry about One Health and generally managing risks, we have to also wonder about whether this is related to something like the Nile River and water use or something else. Here are drier regions which potentially provide a much smaller range of health outcomes in terms of cholera through the year, whereas once you get into these wetter, humider regions, you have much more range of much more seasonality here. So sorry, this is happening throughout the year, whereas as soon as you get into these regions there is a high seasonality, and there is also high seasonality here but low seasonality here. So this is rather surprising, so one has to figure out exactly why there is high seasonality in some places but not in other places. Okay. There are many studies that have focused on West African countries like Senegal and so on, which have looked at seasonalities. You can see also some hotspot here which has high seasonality surrounded by low seasonality regions. So those kind of population specific outcomes or climate specific outcomes have to be understood as well. In terms of the hydrologic processes, precipitation and temperature changes obviously affect fresh and marine water quantity and quality, primarily through urban, rural, and agricultural runoff. This runoff in turn affects human exposure to water-related illnesses, primarily through contamination of drinking water, recreational water, and fish and shellfish. So exposure pathways can be different. This is from the US Global Change Research Report, so obviously much more relevant for the US, but nonetheless the processes are relevant for everybody, and the processes also tell us something about what kind of adaptation measures we will need to reduce the burden of waterborne diseases in terms of mortality and morbidity as we go forward with urbanization, population increases, temperature and precipitation changes, and so on. So we have increasing frequency and intensity of precipitation, farm and livestock runoff, so land use change in addition to agricultural activities, nutrient loadings, and so on. Urban runoff, which tends to be high for the same amount of rain on a paved surfaces of the urban land use than the non-urban land uses, for example, and agricultural runoff will be higher than forest land use, for example. So nutrients and contaminant loading depend on that. Groundwater inundation and groundwater contamination because of agricultural activities affect also the nutrient cycling, sediment exchange, harmful algal blooms, and pathogens in the water, especially when combined with warming of the oceans, especially in the coastal and estuarine waters. Water treatment plants releasing waste or nutrients into the water bodies, residential runoffs, increasing sea surface temperatures that I mentioned, and groundwater mining can also create salinity invasions into the groundwater, and so on and so forth. So these are the kind of typical processes in the rivers, estuaries, and oceans, and the land to ocean continuum that we have to worry about, and each one of them has a outcome it can be thought of in terms of climate sensitive agents of water related illnesses. Again, this is from the US but relevant for the rest of the world. It can be looked at as pathogen or toxin producer, exposure pathway, selected health outcomes and symptoms, and major climate correlation or driver, the strongest drivers listed first here. Okay, so let's just run through this. Algae, toxigenic marine species like Alexandrium, Pseudonychia, Dinophysis, Gambierdiscus, Carenia brevis. We won't go into the detail, but basically they can produce temporary amnesia, paralytic diseases, gastroenteritis, and so on and so forth. For example, Carenia brevis produces a toxin that gets aerosolized and can affect humans that are even walking on the coasts, not even getting into the water, and so on. Cyanobacteria, multiple freshwater species producing toxins including microcystin. Enteric bacteria and protozoan parasites like Salmonella enterica, Campylobacter, E. coli, Cryptosporidium, Giardia, and enteric viruses like enteroviruses, rotaviruses, noroviruses, hepatitis A and E, Leptospira and Leptonema bacteria, Vibrio bacteria species. Exposure pathways include consumption of fish, shellfish, recreational waters, or aerosolized toxins like brevitoxin from Carenia brevis, drinking water, recreational waters, recreational waters and shellfish, and so on. So the exposure pathways are also going to determine the outcomes. Selected health outcomes: gastrointestinal, neurological, shellfish poisoning, fish poisoning, asthma exacerbation, eye irritations, liver and kidney damage, neurological disorder, respiratory arrests, and enteric pathogens. Here, mild to severe flu-like illnesses from leptospirosis. This Vibrio depends on species. Vibrio cholerae will give you diarrhea, whereas Vibrio parahemolyticus also gives diarrhea, slightly different cold water species, whereas Vibrio vulnificus gives you necrosis and septicemia. So watermen who are working in the water for with crabs, fish, and so on, if they have open wounds, the Vibrio vulnificus can cause serious septicemia, hospitalizations, and a few deaths per year as well. Major climate correlations or drivers: temperature, ocean surface currents, ocean acidification, hurricanes, temperature, precipitation patterns, temperature changes related to air and water, both increases and decreases, heavy precipitation, flooding, temperature, heavy precipitation. So we're talking about all hydrological processes here that correlate with the population abundances and also exposure pathways of these pathogens and toxin producers. Okay, HABs or harmful algal blooms is a common terminology. Now there is plenty of evidence that there is increasing warming and acidification of the oceans, which are creating increases in HABs and pathogens, increased exposures, increased consumption of seafood in developing countries like India and China, where meat consumption and fish consumption goes up, also increases exposure to these pathogens through these pathways that we talked about with interactions with climate. And aquaculture adds to this complication as well, because to meet the increasing seafood demand and to export food, cash crops like shrimp, China and India dominate the aquaculture business, and there is fish farming business for salmon and other fish. All these are happening in a warming world. All these are related to waterborne diseases. So we have to always worry about these things. Okay?